We are conducting a sieve analysis on 1220 PW Gillibrand filter pack sand. My son Jared is performing the procedure. My name is Mike. The first step is weighing the sample to be analyzed. This sample is approximately 300 milliliters and weighs 330 grams. Next, the sample is poured into the top of a stack of sieves, with the bottom having a pan. In this case, the first sieve is a number 12, having the largest mesh size, with the last being a number 25. Step number 3 is placing a cover on the top and securing the stack in the sieve shaker set for 10 minutes. Once time has elapsed, the sieves are removed and separated one at a time, with the remaining contents of each individual sieve weighed and recorded in our custom spreadsheet. Sand designated as 1220 is generally graded so that nearly 100% passes a number 12 sieve, with close to 0% passing a number 20 sieve. For our applications, we insist these margins be no greater than 5%. Consistency is important. We prefer for the greatest percentage of sand to be grouped in the middle of the mesh ranges. Sand retained by the number 12 sieve weighs 1.9 grams, which is 0.58% of the total. The filter pack must be sized to limit the volume capable of passing the width of the openings through the intake section of the well. The most common slot size for PVC casing used for domestic wells is 0.032 inches. The smallest filter pack size compatible with a 0.032 slot is 1220. Since 1996, we have been using 1220 filter pack sand exclusively for our domestic wells. Industry consensus is that the median filter pack grain size should be 4 to 6 times the median aquifer grain size. When the gradient of the aquifer grain size is relatively uniform, the filter pack size should be reduced. Sieve number 14 retains 68.3 grams or 20.7% of the total. Due to government regulation, the number of sand quarries in general and the number of specialty sand companies in particular has plummeted over the years. During the same period, the cost of the material has skyrocketed more than 1,000%. The sand we are working with today is brought in via rail car out of Texas. The cost per truckload is $300 to $500 per ton. The rounded shape of this Texas sand makes it very desirable for use as filter pack material. California sands are typically angular, which can cause them to lock together during well development. This condition has a tendency to restrict water flow into the well and thereby reduce overall production. Sieve number 16, 116.8 grams, 35.39%.
Filter pack sand is delivered to us 24 tons at a time by semi-trucks on flatbed trailers. The sand is packaged in 3,000-pound bags called super sacks. These super sacks are made from woven poly fabric. At the bottom, they have a chute at the center for dispensing product, with a cover at the top which opens to full size for filling. They are sewn together as a cube with 4 lifting straps, one at the top of each corner. The sand contents is washed and then kiln dried before placing in the super sacks. Upon delivery, each super sack is placed on a pallet and covered. This black pallet cover protects the super sacks from UV rays and its contents from moisture and contamination.
Number 18, 109.9 grams, 33.3%.
We purchased our sieves to do analysis on samples from monitoring wells that the State Water Board was requiring around dairy lagoons. The procedure was basically the same, except the shaking had to be done manually. Boy, was that tiring on your arms. Later, we began having issues with our previous sand supplier. In fact, we rejected a load without even doing an analysis because the sand appeared to have too many fines at the low end. The replacement load also looked questionable, but we were almost out by then and decided to keep it. An analysis showed there to be just under 10% passing the number 20 sieve. According to industry standards, that is an acceptable amount.
Number 20, 23.8 grams, 7.2%.
We took delivery of one final load from that supplier. Again, the sand looked questionable. We were so concerned that we decided to test every super sack. There are 16 3,000-pound super sacks in a 24-ton shipment. At that point, we decided to buy a mechanical sieve shaker. The super sacks hold about 36 inches of sand. In order to obtain a sample representative of the entire sack, we borrowed a grain probe from one of our friends in the harvesting business. As it turns out, the load was inconsistent, with half the sacks having fines less than 10% and half having fines greater than 10%, passing the number 20 sieve. In fact, one sack had almost double the maximum recommended amount at 19%, passing the number 20 sieve. We ended up keeping track of each sack and purchasing a casing with a .025 slot size to compensate.
Number 25, 3.5 grams, 1.06%.
When I started drilling wells back in the late 70s, we used 3/8 pea gravel for filter packing. In those days, we called it gravel packing. As time went by, the size of the filter pack became smaller and smaller. By the early 80s, I was using number 3 gravel, and when the late 80s came, I was using number 6 sand. All this material came from close proximity, with only the number 6 specifically designated filter pack. In the early 90s, I graduated to 816 sand produced at a plant near Monterey, California. This was the first sand that was kiln dried and more than double the price of sand available locally.
The weight of the sand passing the number 25 sieve and ending up in the pan is 4.6 grams.
As mentioned, by the mid-90s we were using our current 1220 sand. As a reference, that sand is less than 1/16 inch in diameter, or more than 6 times smaller than the sand I started out using. In the late 2000s, we began receiving sand in super sacks. Prior to that, sand came bulk in a set of transfer dump trailers.
Note, in this case there is a 1.7% loss, primarily the result of sand caught in the sieve meshes.